Welcome back to Math Nerds. Today we learned how to use D notation to guide us through the chain rule. Okay, because it can get confusing. I understood one day we had a lot of problems with this, but hopefully using this notation, once you learn how to use it, it shouldn't happen again. Okay? You'll be way more comfortable using the chain rule. I have a couple of easy examples here. What I mean by the chain rule is we're going to take the derivative. This is prime notation. Okay? And this is the notation I need you to use to guide you through. And remember, x, we're not accustomed to seeing this, but for the purpose of this lesson, I'm going to write the inside function as x and the outside function something squared. And every time we take the derivative of that something, we have to take the derivative, multiply it times the derivative of the inside. And we're going to consider x the inside. And what are we going to do? Take the derivative of x squared, which is 2x. Okay? And the derivative of x with respect to itself is 1. Okay? And there's the chain rule. Of course, you didn't have to show this step or here, but for the purpose of this lesson, I need you guys to see. Okay? You're still taking the derivative of x squared with respect to x. Now, example 2 is a little bit more apparent as to why we use it. Okay, we have our derivative of the x equals, and here's D notation and why it's so helpful to use. Start off with the whole function, the derivative of the whole function, but now we're not taking the derivative with respect to x, we're taking the derivative with respect to x plus 2. Meaning, we leave x plus 2 alone just like we left the x alone here, and we work around it. Okay? Then you have to take the derivative of whatever the inside function is, which is this right here. So then we'll take the derivative of x plus 2, and with respect to anything inside is just x. Okay? And we have something similar as we did before. Whatever you write down here, write up here. And you end up with the derivative of x plus 2 squared quantity squared over the derivative with respect to x, and just write the answer. So take the derivative of this whole thing, leaving x plus 2 alone. Okay, leaving x plus 2 alone gives us 2. Leave x plus 2 alone to the 1. I'm not going to write the 1, and the derivative times the derivative of x plus 2. Is 1, leaving us with our answer. Alright, so first thing I need you guys to notice here is with these functions, if the square is immediately after the variable, then keep in mind it only pertains to the variable, not to the trig function. Okay? And so, the derivative of this function here is the derivative of sine x squared and now the inside function is x squared. That's the function we're going to leave alone. So we're taking the derivative with respect to x squared and leaving it alone. Then we're going to multiply it times the derivative of the inside function, x squared, with respect to now the inside function is x with respect to x. And see, you take the whole derivative of the whole function with respect to x. And you stop until you don't stop taking derivatives until you get to with respect to just x alone. And so the derivative of this function, leaving x squared alone, the derivative of sine is cosine. Leaving x squared alone, then we're going to multiply it times x, the derivative of x squared, which is 2x, with respect, leaving the x alone. And there's your answer right there. Now, I'd rather see it in this order, like that. Okay. Okay, so what we need, two things we need to notice is we have a constant in front and we have a squared here. And to rename it, we have 2, and this is how I'd like you to rename it because it's easier to recognize what goes inside of what. Okay, now this whole thing is squared. That's what this means right there. That square means right there. We're squaring everything associated with the cosine. That's cosine x cubed. The 2 is not part of the cosine function. X cubed is. So we square the whole trig function. Okay? Let's write the whole function out, except we need to bring that 2 out here. Constant multiple rule, bring that 2 out. Now, it's clear to see that this whole thing is the inside function. That's what we need to take the derivative with respect to, the whole inside function. Leave that whole inside function alone. Okay? Then multiply that inside function, the derivative of the inside function. With respect to, now there's another inside function here. Leave that inside function alone now. So you're working your way in. Now multiply this times the derivative of this final inside function. And then we can stop with respect to x. There's the inside function. And showing how the math just seems to work out. Those cancel, those cancel. And by doing this whole process, you're actually taking the derivative of cosine of this whole function with respect to x. And let's just finish it out now. We have our 2 carrying down the 2. And we'll go ahead and just keep this locked down. It's not really necessary. I just like to do it for my own reasons, to keep things organized in my own head. It's not necessary. Derivative of this whole thing, leaving this inside part alone right here. 2, bringing that 2 over, okay? 2, leave the inside part alone. Okay, now multiply the derivative of cosine, but leaving x cubed alone. So the derivative of cosine, careful here, is a negative sign. Be careful not to put minus sign. It's times negative sign. Leave that x cubed alone. That's what this is indicating. Okay. And then finally, the derivative of x cubed, which is 3x squared. Now we can combine coefficients. Okay, we have one here, here, and here. 2 times 2 is 4, times 2 is 3. Times 3 is 12. Wow, excuse me. And just finish writing everything out. And the negative as well. Bring that negative to the front too. And there you have it. Now here are the examples that we worked on in class, and I'm just going to breeze right through them, pause it, see if you can work on it on your own if you need to practice. If not, just flip right through it. Okay. So the answer to this one, and go ahead and pause it now. I'll show it in about 3, 2, 1, and there you have it. Okay. Now be careful. You can bring that 2 out and then take the derivative of everything else and then bring that 2 back in like we did here. Okay. Okay. Now go ahead and try it, and I'll show the answer in about 3, 2, 1. There it is. Okay. And so here are the answers for the last few examples. I believe it was C through H, probably. I'm going to go ahead and show you the answers now in case you need to see them really quickly. If you want to pause it now to just try it out, go ahead and do so now. Okay, so here are the answers. Okay, we renamed sine of x here. Okay, move the square to the outside. Now it's clear to see what the inside function is. So derivative of the whole thing with respect to the inside function times the derivative of the inside function with respect to x. Okay, and here is the answer. Derivative of sine, yeah, and then derivative of sine is cosine. Got it. Okay, same thing here. This is the inside function, sine 2x. So you treat that as if it's like an x. Take the derivative around it. Okay, giving you 2 sine 2x, and then derivative of sine of the sine 2x, and the inside function is 2x. Leave that 2x alone, giving you cosine of 2x. Take the derivative of sine only. Leave the 2x alone. Now take the derivative of 2x, leaving you with the x. I mean 2. And just bringing that 2 out to the front, giving you your final answer. Okay, there you go. 2 different ways you can leave your answer. And there you go. And I believe that's your final one. Okay, so next I'm going to go ahead and do the odd problems that you were supposed to do in class. Your homework problems are the evens, 2 through 14 evens. And that's going to be on the next video for you guys. And I believe that was for page 44. Page 44. Sorry, 49. Page 49.